This is problem number 38, and it's a fairly straightforward problem once you understand how to take the language you're given and turn it into meaningful mathematics. So we're told that there is a loss amount X, we're given a deductible C and a constraint on that deductible. We're given a function for our loss amount and constraints on that function. And then this is the key thing to understand because it dictates the values of our integration, or the boundaries of our integration. The loss amount is the payment plus the deductible. So in other words, X equals payment plus C. So here's the integral we're going to solve to get our answer. Usually we would integrate from 0 to 1 if we wanted everything, or we would integrate from 0 to X. But we're told that given a random loss of X, the probability that the insurance payment is less than 0.5 is equal to 0.64. So we're going to set the integral equal to 0.64. But the probability that the insurance payment is equal to 0.5. So let's kind of restate that right there. Is less than or equal to 0.5. And then that's going to equal 0.64. So the point that I'm trying to get at here is that the upper bound of our integration is going to be the loss payment plus the value of the deductible, which is ultimately what we're trying to solve for. So we write out our integral, roll that up, evaluate from 0.5 plus C and 0. And all of that's going to be equal to 0.64. So I'll write that in just a moment. 0.5 plus C squared. Subtract 0 squared is not going to matter. So there's our 0.64. Square root both sides. Technically, you get two values, 0.8 and negative 0.8, but the negative 0.8 isn't useful in this case. Subtract 0.5 from both sides, and there we are. The value of our deductible is C, and we can have at least some confidence that we are correct because it is within our constraint, and it is right there in our answer choices as B. So loss amount is payment plus deductible, and that serves as the upper bound of our integration.